we can use a second derivative to determine the concavity of a function over its domain. So if we look at the open interval from minus infinity to 0.7, the second derivative is positive. So therefore the graph is concave up. And over the open interval from 0.7 to infinity, the second derivative is negative. So therefore the graph is concave down. And we can observe that when the second derivative is 0, that's an inflection point where there's a transition in curvature of the function's graph. And if we look at a critical point and take the slope of the tangent to the curve slightly after, well, we can see that the finite change in the slope of the tangent to the curve with respect to x is less than 0 here. So a negative slope minus a 0 slope. And that's consistent with our second derivative. The second derivative can tell us whether a critical point is a local minimum or maximum. So recall that at a critical point, the slope of the tangent to the curve is 0. And to determine if it's a minimum or maximum, we take the second derivative. So if the second derivative is greater than 0, then our graph is concave up in the vicinity of that critical point. And therefore, the critical point is a local minimum. Now for this critical point, the slope of the tangent to the curve is also 0. But the second derivative is less than 0. So therefore the graph is concave down in the vicinity of that critical point, and it's a local maximum. And that's consistent with the graph of the second derivative over here. Let's use a second derivative test to determine if the critical points are maxima or minima. So we can see that the critical points where the curve changes direction is at x equals 0, 2, and 4. So if you took the derivative of this function, you're going to get x cubed minus 6x squared plus 8x. And then if you take the second derivative, you're going to get 3x squared minus 12x plus 8. And if you substitute for x equals 0, well, what we'd get is y dash dash of 0 is equal to 8. And given that's a positive value, our critical point at x equals 0 is a minimum. And if you substitute x equals 2, you're going to get a negative value for a maximum. And for x equals 4, you're going to get a positive value for a minimum. So really have a think about why a positive value gives us a minimum. Now to find the inflection points, what you do is set y dash dash of x to 0. And then you'll get two solutions. So your inflection points are going to occur somewhere near x equals 1 and near x equals 3. So at x equals 1, the curve changes from concave up to concave down. And at x equals 3, you have concave down changing to concave up.